A sequence is a list of numbers in a specific order, often following a particular rule or pattern. To find the general term of a sequence, you need to understand how the numbers progress and identify the formula that represents the pattern. In a linear sequence, the difference between consecutive terms is constant. The nth term of a linear sequence can be found by observing the pattern in the differences and using a general formula. The nth term is typically written in the form n plus b, where a represents the common difference and b is a constant. For example, in the sequence 3, 7, 11, 15, the difference between terms is 4. The nth term would be 4n1, as for each value of n, the sequence aligns with this expression. For quadratic sequences, the difference between consecutive terms is not constant, but the second difference, the difference of the differences, is. The nth term of a quadratic sequence takes the form n squared plus bn plus c, where a, b, and c are constants. To find these constants, you must first identify the second difference and use it to determine a, then solve for b and c by using specific values of the sequence. For example, in the sequence 2, 6, 12, 20, the second difference is 2, indicating a quadratic form, and the nth term can be calculated as n squared plus n. To determine if a number belongs to a sequence, you can substitute it into the nth term formula and see if it fits. For example, if you are given the nth term as 3n plus 1, you could check if 19 is part of the sequence by solving 3n plus 1 is equal to 19. If n comes out as a whole number, then 19 is a term in the sequence. There are other types of sequences, including geometric sequences where each term is multiplied by a constant to get the next, and Fibonacci-type sequences where each term is the sum of the previous two terms. Geometric sequences have the general form r to the power of n-1, where r is the first term and r is the common ratio. For example, in the sequence 2, 6, 18, 54, each term is multiplied by 3, so the nth term is 2 times 3 to the power nu-1. Sequences are also useful for solving problems, especially when they involve patterns or regular intervals. For example, if you're tasked with finding the total number of objects after a set number of intervals, sequences provide a systematic way to predict future values. Understanding sequences and their nth terms helps solve a wide range of mathematical problems, from simple arithmetic progressions to more complex patterns involving quadratics or other sequences. By mastering this concept, you can efficiently tackle problems that involve predicting or recognizing number patterns.